Hi, it's Peyton. I heard you were looking for some help formulating systems of equations. Let me see what I can do to help you. The toughest part about tackling these problems is translating information given in a word problem to mathematical equations. Okay? And I'm going to give you a general idea of how to work through this. The first thing we should do when faced with one of these problems is to read through the problem thoroughly and pick out the important information we're going to use later to formulate our equations. The second step that we should do is to give variables or symbols to the information we're going to be modeling. And third is to use the information that we have found in the word problem and use the variables to make the mathematical equations. Now, let's work through a couple of examples to get a better idea of how to do this. Here's our first one. Two friends, Xavier and John, have 50 DVDs between the two of them. John has 2 more DVDs than 3 times the amount of DVDs Xavier has. What is a system of equation for the information given? First step, let's identify the important information from the problem. We know that between the two of them they have 50 DVDs, and we know that John has 2 more DVDs than 3 times the amount of DVDs Xavier has. Okay? That's the first step. Now, let's give variables to the quantities we're trying to model. I'm going to let x equal the number of DVDs Xavier has, and I'm going to let j equal the number of DVDs John has. Now the tricky part, developing the equations. Let's use the information from the first step, and we're going to use our variables. First thing, we know that between the two of them they have 50 DVDs. So if we want to write this mathematically, we would say that x plus j equals 50. The quantity of DVDs that Xavier has plus the quantity of DVDs John has equals 50. Now for the second equation. We know that John has 2 more DVDs than 3 times the number of DVDs Xavier has. I would say that j is equal to 3x plus 2. The number of DVDs John has is equal to 2 more than 3 times the number of DVDs Xavier has. And we see that that fits the information we're given. And so here are our equations. 50 is equal to x plus j. 50 DVDs is equal to the number of DVDs Xavier has plus the number of DVDs John has. And our second equation is j is equal to 3x plus 2. The number of DVDs John has is equal to 2 more than 3 times the number of DVDs Xavier has. Okay? Pretty simple, right? Let's work another example. There are 3 chicken farmers. I don't know why they're raising chickens, don't ask me. Their names are Roger, Charlie, and Paul. Together, they have a total of 75 chickens, but Charlie has 1 less than 2 times the number of chickens that Paul has, and Roger has twice the number of chickens that Charlie has. What is a system of equation to model the information? We know that the total number of chickens that the 3 farmers have is 75. We also know that Charlie has 1 less than 2 times the number of chickens that Paul has, and we know that Roger has twice the amount of chickens that Charlie has. Now, our second step, let's give variables to the quantities we're trying to model. I'm going to let C equal the number of chickens that Charlie has. I'm going to let P equal the number of chickens that Paul has, and I'm going to let R equal the number of chickens that Roger has. Okay? Now, the third step. We're going to construct our equations using the information we're given and the variables we have. The first equation is we know that altogether the farmers have 75 chickens. So I would say that C plus P plus R is equal to 75. The quantity of chickens that Charlie has plus the quantity of chickens that Paul has plus the quantity of chickens Roger has is equal to 75. Now for the second equation, we know that Charlie has 1 less than 2 times as many chickens than Paul has. Okay, so Charlie has 1 less than twice the number of chickens that Paul has. So I would say the equation is this. C is equal to 2P minus 1. The quantity of chickens that Charlie has is equal to 1 less than twice the quantity of chickens that Paul has. Okay? Now our third equation is this. R is equal to 2C. Okay, and this comes from the information that Roger has twice the number of chickens that Charlie has. Okay? Now here's our system of equations. C plus P plus R is equal to 75, the quantity of chickens that Charlie has, plus the quantity of chickens that Paul has, plus the quantity of chickens that Roger has, is equal to 75. Our second equation is C is equal to 2P minus 1. The quantity of chickens that Charlie has is 1 less than twice the quantity of chickens that Paul has. And our third equation is R is equal to 2C. Roger has twice the quantity of chickens that Charlie has. Okay? Pretty simple. Now, let's work one more example and take a very, very, very close look at that third step. Okay? We're told that an admission fee for a small fair is $1.50 for children, and it's $4 for adults. On a certain day, 2,200 people enter the fair, and a total of $5,050 is collected. What is a system of equations which could be used to model this information? First off, I'm going to go ahead and kind of skip the first step. I'm going to let A be equal to the number of adults admitted, and I'm going to let C be equal to the number of children admitted to the fair. Now let's create our systems of equations. We are told that on a certain day there are 2,200 people admitted to the fair. So that means the number of adults plus the number of children has to equal 2,200. Or, mathematically, it would be A plus C is equal to 2,200. That's our first equation. Let's move to our second equation. We're going to use the information that on a certain day, $5,050 is collected, and that the charge for children is $1.50, and that the charge for adults is $4. So the charge for adults times the number of adults plus the charge for children times the number of children has to equal $5,050. It's a bit clunky, but let me show you what this is mathematically. It's 4 times A plus 1.5 times C is equal to 5,050. Not as ugly anymore, is it? Here's our equations. We're going to use the cost equation first. 4A plus 1.5C is equal to 5,050. And then our second equation is the admittance equation. A plus C is equal to 2,200. The toughest thing about formulating systems of equations is translating the information we're given to mathematical equations. And we're going to work one more example that gets a little hairy. We're told that the air mail rate for letters sent to Europe is 45 cents per half ounce, and to Africa is 65 cents per half ounce. If Shirley paid a total of $18.55 to send 35 half-ounce letters abroad, what is the systems of equations to model this information? Okay, let's let E be the number of letters sent to Europe, and we're going to let A be the number of letters sent to Africa. We know that 35 letters were sent total. Shirley sends 35 letters total, so that means that E plus A has to equal 35. The numbers of letters sent to Europe plus the number of letters sent to Africa is equal to 35. The other equation is given by the information that each letter sent to Europe cost 45 cents and that each letter sent to Africa costs 65 cents. And the total cost for Shirley to send those letters is $18.55. Mathematically, that would be, we're going to write 0.45 times E plus 0.65 times A is equal to 18.55. And we need to, let me explain to you why I have these decimals here. We're told it's 45 cents. We can't just write 45 there, because if we write it like that mathematically, we're saying it's $45 per letter. So just bear that in mind. And here's what our systems of equations would look like. E plus A is equal to 35. The numbers of letters sent to Europe plus the number of letters sent to Africa is equal to 35. And then our cost equation, 0.45 times E plus 0.65 times A is equal to 18.55. The cost to send a letter to Europe times the quantity of letters sent to Europe plus the cost of letters sent to Africa times the numbers of letters sent to Africa is equal to 18.55. That's the systems of equations for you. I'll catch y'all next time.